Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson, and today we're going to be talking about finding the linear approximation of a function, as well as discussing the quadratic approximation of that function as well. So, if you have any questions, please leave them in the comments, as well as any other problems that you would like me to do. So let's jump into this. So we're asked to find the linear approximation in the quadratic extension, or the quadratic approximation, for the function f of x equals x to the 1/2 minus x to the 3/2 at a equals 4. So let's take a look at the linear approximation. So we'll represent that by L, and it'll be L of x, and that's equal to f prime of a times x minus a plus f of a. So this here is the general linear approximation form, and we are going to fill this in with the derivative f prime and evaluate f prime at a and the original function at a as well. So let's go ahead and do that. Okay, so let's find f prime first. So f of x is equal to x to the 1/2 minus x to the 3/2. So we'll take the derivative of that. So f prime of x is equal to 1/2 times x to the 1/2 minus 1, which is negative 1/2, minus 3/2 times x to the 3/2 minus 1, which is 1/2. So now we need to evaluate both of these at 4. So f of 4 is equal to 4 to the 1/2 minus 4 to the 3/2. And 4 to the 1/2 is 2, because that's just asking to find the square root of 2. And then 4 to the 3/2 is the square root of 4 cubed. And so that's going to be 4 minus 8, or 2 minus 8. 2 minus 8, which is negative 6. Okay, and let's go ahead and find f prime of 4. So f prime of 4 is going to be equal to 1/2 of 4 to the negative 1/2 minus 3/2 times 4 to the 1/2. So 4 to the negative 1/2 is 1 over the square root of 4, which is 1/2. And then times 1/2, so that's going to give us 1/4, minus 3/2 times 4 square root of 4, which is 2. So then we get 1/4 minus 3, which is 1/4 minus 12 quarters, which is negative 11 quarters. So plugging everything into our linearization formula, we get L of x is equal to f prime at 4, which is negative 6, times x minus 4 plus f of a, or f of 4, which is, that's negative 6. And then the negative 6 up front should actually be negative 11/4. Usually you can just leave it like that, or you can simplify that down if you like and turn that into an actual line. So let's take a look at the quadratic approximation. So the quadratic approximation, call that q of x, is going to be equal to f double prime of a times x minus a squared plus f prime of a times x minus a plus f of a. And there's one thing you've got to do, is that f double prime of a has to be divided by 2. It's part of the formula for the quadratic approximation. So what do we need now? Well, we've got most of this, we just need f double prime of the second derivative of f evaluated at 4. So we have f prime of x is equal to 1/2 times x to the negative 1/2 minus 3/2 times x to the 1/2. And we'll take that derivative again. So f double prime. So we'll bring the negative 1/2 down and multiply that by positive 1/2, gives us negative 1/4 times x to the negative 3/2. And then the 1/2 comes down and we get minus 3/4 times x to the 1/2 minus 1, which is negative 1/2. And so we need to evaluate that at 4. So that's going to be negative 1/4 times 4 raised to the negative 3/2 minus 3/4 times 4 raised to the negative 1/2. So let's start to clean this up a bit. So that's negative 1/4 times, so 4 to the negative 3/2, that's the square root of 4, which is 2, raised to the negative 3, which is 1/8. Minus 3/4 times 4 to the negative 1/2, which is 1 over the square root of 4, which is 1/2. And so combining those terms, we get negative 1/32 minus 3/8. And that is negative 1/32 minus 12/32, which is negative 13/32. So now we need to fill in everything. So we know what f double prime of a is. We just found that. That was negative 13/32. And that's all going to be divided by 2 times x minus 4 squared plus f prime of a, which was negative 11 over 4 times x minus 4. And then plus f of a, which was minus 6. I'll just put minus 6 there. And we'll clean this up just a little bit. So negative 13/32 divided by 2 is going to be negative 13 over 64. And that's it. So we found both the linear approximation and the quadratic extension of that approximation. And that completes our problem. Thanks for watching, and we'll see you in the next video.